One of the very first things that AP statistics students struggle with is the idea of marginal and conditional distributions. Um, it is kind of a weird concept. I don't think it's too difficult, but the first time through, I think the wording is hard, and I think that you just need to see it a couple of times. As this slide suggests, I really am a truly huge Maryland Terrapin fan. I happened to go to college there during the height of our rivalry in basketball with Duke University. So not only am I a Terp fan, but Duke is one of the four-letter words you are absolutely not allowed to say in our classroom. So keep that in mind as the year progresses. Here we can see some absolutely fictitious data that I took. Because I know that I have a biased opinion against Duke, I needed to look at this in a little more analytical way. Again, this data is fake, but you can see that I'm measuring what the relationship between selling your soul to the devil and attending Duke is. We'll see this we'll see this table again as we continue on in the slideshow. Okay, so example one, find the marginal distribution of the variable, did the student sell their soul? A marginal distribution, the values that we're going to use to calculate it all come from the margin of the table. That's why it's called a marginal distribution. So in this particular case, I want to know the marginal distribution of the variable, did the student sell their soul? So I'm looking at this and this category, and I'm figuring out these totals out of everybody in the table. So every number that I'm going to need comes from the margin of the table. All right, so we're going to have two parts to this. We're going to have a yes part, and that is 15 out of 600, or 2.5%. And we're going to have the no, which is obviously everybody else. So that's 585 out of 600, and that works out to the remaining 97.5%. Okay, that's the marginal distribution of the variable, did the student sell their soul? That simple. We could ask for a different marginal distribution, but the idea is still the same. So let's take a look at that now. So find the marginal distribution of the variable school attended. So in this particular case, we had 51 students who went to Duke. So the marginal distribution for that is 51 out of 600. And that is, let me grab my calculator real quick. 51 out of 600 is 8.5%. So 0 here. And for other, it is the remaining 549 out of 600, or 91.5%, so 0.195. Okay, so that is marginal distribution. You look at the variable we're talking about, so school attended here. School attended is broken into two categories. We've got Duke and we've got other. So we look at how many went to Duke in our sample, and we figure out that percentage, and we compare that to the percentage that went to other schools. Very simple concept, complicated name. You just need to remember that margin means that all the values are coming from the margins or the kind of totals columns of your table. Let's move on now to the more complicated concept of conditional distribution. The key here is to look for the word by. So you can see here that we are looking for the conditional distribution of school attended by, did the student sell their soul? So in other words, what we know about these people in the first instance is they sold their soul. And to continue with the conditional distribution, we're going to hold constant the idea that they did not sell their soul. Really what we're asking here is, what is the probability that among all the people who said yes, if you randomly selected one out of that group, what's the probability they attended Duke? So the Duke part of that would be 8 out of 15, which works out to about 53.33%. So I'm going to go ahead and put that here. And, it's pretty easy to see that if 53.33% of all those who said, yes, I sold my soul to the devil, went to Duke, that 46.7% of those who said, yes, they sold their soul to the devil, attended other schools. So now let's move on to the no category, where we have 585 total people, of which 43 went to Duke. So if I know the person said no, they did not sell their soul, and I want to figure out what's the probability they went to Duke, I would do 43 out of 585, or 7.4% roughly. Okay? So if I randomly selected somebody from the group who said no, right, we have to know they said no, 7.4% of those would be Dookies. And likewise, 92.6 will have gone to other schools if we know they said no. Notice that if we move down this column this way, these percentages add up to 100%. Okay, likewise, moving down the other column, that adds up to 100%. Of course, we can also condition the other way, and that's what we're going to go ahead and do on the next slide. I think it would be a really good idea for you to take a moment and pause the video and go try to condition the other way. So this time you can see that we're looking for the conditional distribution of did the student sell their soul by school attended. I'm going to shut up for a couple of seconds to allow you to pause the video and try this one on your own. Okay, I hope that you looked at this and you said, what we're going to hold fixed this time is the school attended. So these should be your denominators this time. And you should have two fractions involving each of those denominators. So among those who went to Duke, we're going to look at the yeses. And that is 8 out of 51 for 15.7%. Let me make sure I did that right. I feel like maybe I hit a button wrong there. 8 out of 51 is in fact 15.7%. So 0.157 goes here this time, which means the remaining 84% of those who went to Duke, or 84.3% who went to Duke, did not sell their soul. So 0.843. I'd be hard pressed to find those 84.3%, but you know, that's what they say. All right, and among the other group, those who said yes, yes, and the other is 7 out of 549, which works out to about 1.3%, which we'll put right here, 0.13, meaning that 98.7% of those who went to other schools did not sell their soul to the devil. Again, notice that these percentages this time are adding up to 100%, moving that way across the table. Okay, so that is how to calculate a conditional distribution. You look for what your denominator is going to be, what are we holding fixed, and the other variable gets broken up among the outcomes of that variable. So in this slide, we're supposed to discuss the relationship between which ACC school a student attended and whether or not they sold their soul to the devil, and we're supposed to use a graphic display. So the graphic display I would recommend here is what's called a segmented bar graph. In a segmented bar graph, the y-axis always goes to 100%. And so I'm going to go ahead and do that. This is 100% here. I'm going to be a little lazy. I'm just going to go 50%, and then we'll cut those in half again and count by 25% ultimately. 25% and 75%. Okay, and on this axis, we're going to record whether or not the student went to Duke or another school. And down here, we're going to do whether or not they sold their soul. Okay, so we're going to have a bar for yes and a bar for no. And each bar on a segmented bar graph always goes up to 100%. Man, my scaling is awful here, but that's okay. Just showing you the concept. So both bars go up to 100%. And you want to differentiate the different parts of the bar. So here we're going to have a part of the bar that stands for Duke and a part of the bar that stands for the other schools. And remarkably, in my survey of 600 people, where it's completely unbiased, of course, 53.3% of everybody who said they sold their soul to the devil went to Duke. You don't need to put in the percentages like I am, but I think it's very helpful for the reader to see that, because, you know, I can't visualize, is that 45% or is it 46.7%? That's pretty hard to do. And then in the other bar, among the people that said no, we had 7.4% who went to Duke and the rest went elsewhere. So 7.4%. And I'm trying to show some cross-hatching there. It's a little tough in that little space. And then 92.6% here. Okay, so then we need to make some kind of a key. I'm going to go like this, draw a little block with cross-hatching in it like that. And I'm going to say that that is Duke. And another bar like this. And I'm going to say that's other. Okay, so that's my visual representation. Again, this is called a segmented bar graph. And it's very good when you're trying to show a conditional distribution. Okay, segmented bar graph. Okay, now we're supposed to talk about this as well. So I think the remarkable thing here is, only 8.5% of everybody went to Duke. So while only 8.5% of students in the sample went to Duke, more than half of those who sold their soul did. Of those who sold their soul did. It seems clear there's an association between selling your soul and going to Duke. Okay, notice I did not try to imply cause and effect here. I said there's an association between the two things, right? It could be that people who have sold their soul are more likely to be attracted to Duke, or it could be that going to Duke causes people to sell their soul. We don't know which way that that influence works, but it does seem there's a strong connection between those two things, just based on the graph. So this is an example of using a segmented bar graph to discuss the relationship between the ACC school attended and whether or not they sold their soul to the devil. So I'm going to call it quits for this, and see you in the next one.